You've done this thousands of times. You slide a little serrated piece of metal into a slot, give it a twist, and a door that was completely immovable a second ago just opens. We treat it as one of the most ordinary actions there is. But the shape of that key is doing something genuinely clever, quietly solving a puzzle that's been refined for over 4,000 years. So let's cut one open and watch what actually happens in the half second it takes to unlock a door. Strip away the doorknob and the bolt, and almost every lock you own comes down to one simple idea: a cylinder that needs to turn. There's an inner core called the plug, sitting inside an outer housing called the shell. If the plug can rotate, it drags back the bolt and the door opens. That's the whole job. So really, a lock has just one mission: stop that plug from turning until the right key shows up. And the boundary where the plug meets the shell has a name worth remembering: the shear line. Everything about how a lock works and how it fails happens right there. So how do you jam the plug? You drill a row of little vertical shafts straight down through the shell and into the plug, usually 5 or 6 of them. Into each shaft you drop 2 stacked pins and a spring on top. The bottom one is the key pin. The top one is the driver pin. With no key inserted, the springs shove both pins downward. And here's the trick: the driver pins are sized so that when they're pushed all the way down, they sit halfway across the shear line. Part of each driver pin is in the shell, part is in the plug. They bridge the gap. The plug is now physically stapled to the shell by 5 little metal pins. Try to turn it, and it won't move. Now slide a key in. A key is really just an instruction for how high to lift each of those pins. The peaks and valleys cut into its top edge. The bitting push each key pin up by a specific amount. Put in the wrong key, and the heights are all wrong. Some pins get lifted too little, so the driver pin still crosses the shear line. Others get shoved too high, and now the key pin itself crosses it. Either way, something is always bridging the boundary. The plug stays locked. A wrong key isn't rejected by some sensor. It just fails to line everything up. But the correct key is cut so that every valley and peak lifts its pin by exactly the right height. And when that happens, something quietly beautiful occurs all along the row at once. The gap between each key pin and its driver pin land precisely on the shear line. Every pin is split right at the boundary. For the first time, nothing is crossing from the plug into the shell. The staples are gone. With nothing bridging the shear line, the plug is free. You turn the key, the plug rotates inside the shell, the cam on the back swings the bolt aside, and the door opens. That satisfying little click is the cam catching mechanical confirmation that all 5 pins got out of the way at the exact same instant. 4,000 years of refinement, and it still comes down to lining up 5 tiny gaps. Which raises an uncomfortable question. If a lock is just 5 pins that need to reach the shear line, do you actually need the key to get them there? You don't. And the reason is a flaw hiding in plain sight. Nothing is ever machined perfectly. Those pin shafts are never drilled in a perfectly straight line. Each one is off by a hair. So when a picker puts the faintest turning pressure on the plug tries to rotate a microscopic amount. And one single pin, the most out of line one, binds against the edge first. Push that one pin up to the shear line, and the plug rotates a tiny step further, catching that driver pin on a microscopic ledge. That pin is now set. Then the next tightest pin binds, and you repeat, one at a time, pin by pin, until the last one sets, and the whole plug swings free, no key required. The very tolerance that makes locks cheap to manufacture is the exact weakness that makes them pickable. So next time a key turns in your hand, picture it. 5 springs, 5 pairs of pins, and 5 tiny gaps all snapping into a perfect line you will never see. It isn't magic, and honestly, it isn't even all that secure. It's just a very old, very clever way of asking a question that only the right shaped piece of metal can answer. If you'll never look an everyday object the same way again, that's the whole point of this channel. Stick around. We'll keep cutting things open,